report. Here we go. We have 7,109 cases of COVID, still active cases in the county. We have 173 people in the hospital. There are 31 patients in ICU. And sad to say, there's 298 people, families, friends, loved ones that have passed away from COVID. Number of vaccines, there's 3,824 that were given out by Oneida County Health Systems. There's Oneida County Health Department, I'll say. 2,821 been given out by Rome Hospitals. And Mohawk Valley Health System is going to be St. E's, St. Elizabeth, and St. Luke's in New Hartford that were administered for the vaccine as well, 7,432. All right. One more thing to check out, number of daily cases. I think we could see this. Second wave is definitely forming. Second curve is forming. And it's starting to descend, I think. It looks like it's descending, right now at least. You can see the data. You can see this trend starting to decline. So that is a great sign. On the 18th, we had 151 cases. The 17th was 155. And on the 16th, there was 159 cases. So you can see it's a good trend in the right direction. Let's check out the agenda for today. Today's agenda, we are going through and finishing up chemical bonding. Happy Inauguration Day. The quote of the week comes from Dr. Martin Luther King. We may have all come on different ships, but we're in the same boat now. So we're in the same boat with the next president, same boat with this COVID, same boat for this online learning, and obviously same boat for a chemical class. So might rock a little bit, but we're all in this together. Wednesday, January 20th, 2021 is a day 2. We'll watch the atomic bonding song again. I might skip that and put the president's video on right now. We'll go through some guided notes. We'll watch a video on carbon dioxide, the formation of carbon dioxide, and then we'll end up with covalent bonding. I think instead of watching that again, we'll find the live video. We'll watch this for about
Chief Justice of the Supreme
10
Court
minutes,
of the United
10 minutes, and then we'll move on from there. I think 12 o'clock was a big time for Joe Biden.
States, John Roberts, to administer the presidential oath to the next President of the United States, Joseph R. Biden.
Ladies and gentlemen, please stand for the oath of office, followed by musical honors.
Please raise your right hand and repeat after me. I, Joseph Robinette Biden, Jr., do solemnly swear.
I, Joseph Robinette Biden, Jr., do solemnly swear.
That I will faithfully execute.
That I will faithfully execute.
The office of President of the United States.
Office of President of the United States.
And will, to the best of my ability.
Will, to the best of my ability.
Preserve, protect, and defend.
Preserve, protect, and defend.
The Constitution of the United States.
The Constitution of the United States.
So help you God.
So help me God.
Congratulations, Mr. President.
Ladies and gentlemen, please be seated.
My fellow Americans, a moment we have all been waiting for. It is now my great privilege and high honor to be the first person to officially introduce the 46th President of the United States, Joseph R. Biden, Jr.
Chief Justice Roberts, Vice President Harris, Speaker Pelosi, Leader Schumer, Leader McConnell, Vice President Pence, my distinguished guests, my fellow Americans. This is America's day. This is democracy's day, a day of history and hope, of renewal and resolve. Through a crucible for the ages, America has been tested anew, and America has risen to the challenge. Today, we celebrate the triumph not of a candidate, but of a cause, the cause of democracy. The people, the will of the people has been heard, and the will of the people has been heeded. We've learned again that democracy is precious. Democracy is fragile. And at this hour, my friends, democracy has prevailed. So now, on this hallowed ground where just a few days ago, violence sought to shake the Capitol's very foundation, we come together as one nation, under God, indivisible, to carry out the peaceful transfer of power as we have for more than 2 centuries. As we look ahead in our uniquely American way, restless, bold, optimistic, and set our sights on the nation we know we can be and we must be. I thank my predecessors of both parties for their presence here today. I thank them from the bottom of my heart. And I know the resilience of our Constitution and the strength of our nation, as does President Carter, who I spoke with last night, who cannot be with us today, but whom we salute for his lifetime in service. I've just taken the sacred oath each of those patriots have taken, the oath first sworn by George Washington. But the American story depends not on any one of us, not on some of us, but on all of us, on we the people who seek a more perfect union. This is a great nation, We're good people. And over the centuries, through storm and strife, in peace and in war, we've come so far. But we still have far to go. We'll press forward with speed and urgency, for we have much to do in this winter of peril and significant possibilities. Much to repair, much to restore, much to heal, much to build, and much to gain. Few people in our nation's history have been more challenged or found a time more challenging or difficult than the time we're in now. Once-in-a-century virus that silently stalks the country. It's taken as many lives in 1 year as America lost in all of World War II. Millions of jobs have been lost. Hundreds of thousands of businesses closed. A cry for racial justice, some 400 years in the making, moves us. The dream of justice for all will be deferred no longer. A cry for survival comes from the planet itself. A cry that can't be any more desperate or any more clear. And now, a rise of political extremism, white supremacy, domestic terrorism, that we must confront and we will defeat. To overcome these challenges, to restore the soul and secure the future of America, requires so much more than words. It requires the most elusive of all things in a democracy: unity. Unity. In another January, on New Year's Day in 1863, Abraham Lincoln signed the Emancipation Proclamation. When he put pen to paper, the president said, and I quote, "If my name ever goes down into history, it'll be for this act, and my whole soul is in it." My whole soul is in it. Today, on this January day, my whole soul is in this, bringing America together, uniting our people, uniting our nation. And I ask every American to join me in this cause. Uniting to fight the foes we face: anger, resentment and hatred, extremism, lawlessness, violence, disease, joblessness, and hopelessness. With unity, we can do great things, important things. We can right wrongs. We can put people to work in good jobs. We can teach our children in safe schools. We can overcome the deadly virus. We can reward work and rebuild the middle class and make healthcare secure for all. We can deliver racial justice, and we can make America once again the leading force for good in the world. I know speaking of unity can sound to some like a foolish fantasy these days. I know the forces that divide us are deep and they are real. But I also know they are not new. Our history has been a constant struggle between the American ideal that we're all are created equal and the harsh, ugly reality that racism, nativism, fear, demonization have long torn us apart. The battle is perennial, and victory is never assured. Through Civil War, the Great Depression, World War, 9/11, through struggle, sacrifice, and setbacks, our better angels have always prevailed. In each of these moments, enough of us have come together to carry all of us forward. And we can do that now. History, faith, and reason show the way of unity. We can see each other not as adversaries, but as neighbors. We can treat each other with dignity and respect. We can join forces, stop the shouting, and lower the temperature. For without unity, there is no peace, only bitterness and fury. No progress, only exhausting outrage. no nation, only a state of chaos. This is our historic moment of crisis and challenge, and unity is the path forward. And we must meet this moment as the United States of America. If we do that, I guarantee you we will not fail. We have never, ever, ever, ever failed in America. We've acted together. And so today, at this time, in this place, let's start afresh. All of us. Let's begin to listen to one another again. Hear one another. See one another. Show respect to one another. Politics doesn't have to be a raging fire, destroying everything in its path. Every disagreement doesn't have to be a cause for total war. And we must reject the culture in which facts themselves are manipulated and even manufactured. My fellow Americans, we have to be different than this. America has to be better than this. And I believe America is so much better than this. Just look around. Here we stand in the shadow of the Capitol Dome, as was mentioned earlier, completed amid the Civil War, when the Union itself was literally hanging in the balance. Yet we endured. We prevailed. Here we stand, looking out on the great mall where Dr. King spoke of his dream. Here we stand where 108 years ago, at another inaugural, thousands of protesters tried to block brave women marching for the right to vote. And today, we mark the swearing in of the first woman in American history elected to national office, Vice President Kamala Harris. Don't tell me things can't change. Here we stand, across the Potomac from Arlington Cemetery, where heroes who gave the last full measure of devotion rest in eternal peace. And here we stand, just days after a riotous mob thought they could use violence to silence the will of the people, to stop the work of our democracy, to drive us from this sacred ground. It did not happen. It will never happen. Not today, not tomorrow, not ever. Not ever. To all those who supported our campaign, I'm humbled by the faith you've placed in us. To all those who did not support us, let me say this. Hear me out as we move forward. Take a measure of me and my heart. If you still disagree, so be it. That's democracy. That's America. The right to dissent peaceably within the guardrails of our republic is perhaps this nation's greatest strength. Yet hear me clearly. Disagreement must not lead to disunion. And I pledge this to you. I will be a president for all Americans. All Americans. And I promise you, I will fight as hard for those who did not support me as for those who did. Many centuries ago, St. Augustine, a saint of my church, wrote that a people was a multitude defined by the common objects of their love. Defined by the common objects of their love. What are the common objects we as Americans love that define us as Americans? I think we know. Opportunity, security, liberty, dignity, respect, honor, and yes, the truth. Recent weeks and months have taught us a painful lesson. There is truth and there are lies. Lies told for power and for profit. And each of us has a duty and a responsibility as citizens, as Americans, and especially as leaders. Leaders who have pledged to honor our Constitution and protect our nation, to defend the truth and defeat the lies. Look, I understand that many of my fellow Americans view the future with fear and trepidation. I understand they worry about their jobs. I understand, like my dad, they lay at bed at night, staring at the ceiling, wondering, can I keep my health care? Can I pay my mortgage? Thinking about their families, about what comes next. I promise you, I get it. But the answer is not to turn inward, to retreat into competing factions, distrusting those who don't look like you, or worship the way you do, or don't get their news from the same sources you do. We must end this uncivil war that pits red against blue, rural versus urban, or rural versus urban, conservative versus liberal. We can do this if we open our souls instead of hardening our hearts, if we show a little tolerance and humility, and if we're willing to stand in the other person's shoes, as my mom would say, just for a moment, stand in their shoes. Because here's the thing about life. There's no accounting for what fate will deal you. Some days, when you need a hand. There are other days when we're called to lend a hand. That's how it has to be. That's what we do for one another. And if we are this way, our country will be stronger, more prosperous, more ready for the future. And we can still disagree. My fellow Americans, in the work ahead of us, we're going to need each other. We need all our strength to persevere through this dark winter. We're entering what may be the toughest and deadliest period of the virus. We must set aside politics and finally face this pandemic as one nation. One nation. And I promise you this, as the Bible says, weeping may endure for a night, but joy cometh in the morning. We will get through this together. Together. Look, folks, all my colleagues I serve with in the House and the Senate up here, we all understand the world is watching all of us today. So here's my message to those beyond our borders. America has been tested, and we've come out stronger for it. We will repair our alliances and engage with the world once again. Not to meet yesterday's challenges, but today's and tomorrow's challenges. And we'll lead not merely by the example of our power, but by the power of our example. We'll be a strong and trusted partner for peace, progress, and security. Look, you all know we've been through so much in this nation. And my first act as president, I'd like to ask you to join me in a moment of silent prayer. Remember all of those who we lost in this past year to the pandemic. Those 400,000 fellow Americans, moms, dads, husbands, wives, sons, daughters, friends, neighbors, and co-workers. We'll honor them by becoming the people and the nation we know we can and should be. So I ask you, let's say a silent prayer for those who've lost their lives and those left behind, and for our country. Amen. Folks, this is a time of testing. We face an attack on our democracy and on truth, a raging virus, growing inequity, the sting of systemic racism, a climate in crisis, America's role in the world. Any one of these would be enough to challenge us in profound ways. But the fact is, we face them all at once, presenting this nation with one of the gravest responsibilities we've had. Now we're going to be tested. Are we going to step up, all of us? It's time for boldness, for there's so much to do. And this is certain. I promise you, we will be judged, you and I, by how we resolve these cascading crises of our era. We will rise to the occasion is the question. Will we master this rare and difficult hour? Will we meet our obligations and pass along a new and better world to our children? I believe we must. I'm sure you do as well. I believe we will. And when we do, we'll write the next great chapter in the history of the United States of America, the American story. A story that might sound something like a song that means a lot to me. It's called American Anthem. There's one verse that stands out, at least for me, and it goes like this. The work and prayers of century have brought us to this day. What shall be our legacy? What will our children say? Let me know in my heart when my days are through. America, America, I gave my best to you. Let's us add our own work and prayers to the unfolding story of our great nation. If we do this, then when our days are through, our children and our children's children will say of us, they gave their best, they did their duty, they healed a broken land. My fellow Americans, I close the day where I began, with the sacred oath. Before God and all of you, I give you my word. I will always level with you. I will defend the Constitution. I'll defend our democracy. I'll defend America. And I'll give all of you, keep everything I do in your service, thinking not of power, but of possibilities, not of personal interest, but the public good. And together, we shall write an American story of hope, not fear, of unity, not division, of light, not darkness, a story of decency and dignity, love and healing, greatness and goodness. May this be the story that guides us, the story that inspires us, and the story that tells ages yet to come that we answered the call of history. We met the moment. Democracy and hope, truth and justice did not die on our watch, but thrived. That America secured liberty at home and stood once again as a beacon to the world. That is what we owe our forebears, one another, and generation to follow. So, with purpose and resolve, we turn to those tasks of our time, sustained by faith, driven by conviction, and devoted to one another and the country we love with all our hearts. May God bless America, and may God protect our troops. Thank you, America.
Okay, there's a little snapshot of what's going on in DC right now. So I did want to take a few minutes out of class to show you that, because that is huge history developing right now in life. So in America, this new president, there we go. So feel free to watch the rest of that a little bit later. All right, so I'm going right to my guided notes. So please go to your guided notes. What I have to do today, my main objective for today, is to complete our guided notes. And we're going to put this chart in there that is used to define different types of bonding for chemicals, chemical bonding. So please open up your guided notes. We'll finish it up today. And you could submit it as well. Additionally, I did not go through the rest of the stuff. Let me go through it quick. There is an exit pass that will be due on Saturday. It's on metallic and hydrogen bonding. We will have a midterm next week, either the 26th or 27th. And please review units 1 through 5. Study on up. The midterm is going to be timed, and you have one shot to take it. So if we start, you have one full block to take it. Once you start it, you have to finish it. You can't start it during class and then do the rest of it later. Once you start it, you have to finish it, and you have one full block to do 45 questions. They're all Regents-based questions. If you're doing these warm-ups, you've been paying attention, if you completed your notes, then you should be in a pretty good situation for that midterm. But we will continue to review from here on out till that midterm day. So I left off, we talked about metallic bonding, we talked about hydrogen bonding. It's all multiple choice. Yes, it's all multiple choice. It's the same midterm that all your friends are taking in your other chem classes as well. So if they're taking Regents chemistry, we're all taking the same midterm. All right, so I decided to not play my other video since I played the sworn in of Joe Biden instead, new president. So we will not play any other videos. All right, so we left off talking about covalent bonding. A little refresher. Covalent bonding is two nonmetals sharing electrons. They're stronger bond, stronger attraction for each other. It's tougher to take away the electrons. They cannot be broken down by dissolving or melting. They never can conduct electricity. Why? Because there's no metal. The electronegativity difference is less than 1.7. This is what we're going to highlight today. If the difference is less than 1.7, that means to subtract, then it's going to be a covalent bond. More specifically, for nonpolar means no pole of electrons. It's two nonmetals. If the difference in electronegativity is 0 to 0.3, that's going to be proof it is a nonpolar covalent bond. That means they're sharing electrons equally. It's an equal or even distribution of electrons. You should know what diatomic molecules are. Diatomic molecules, Br2, O2, F2, N2, H2. It's two of the same elements bonding together, two of the same nonmetals that bond together. We should know that a single covalent bond shares one pair of electrons, or 2 electron total. Double covalent bond shares 2 pairs of electrons, or 4 total. And triple covalent bond shares 3 pairs, or 6 total electrons. You should be aware of how to make Lewis dot diagrams for these nonpolar covalent bonds. Br2, O2, F2, N2, H2. What I would do is probably write these on a separate piece of paper and then just take a reference table out and see if I could draw those. I'd practice that. We looked at polar covalent bond. Polar means it has a pole. It's going to be between nonmetals. Its difference is 0.3 to 1.7. Electrons are shared unequally. There's an unequal share of electrons. Someone's being a hog. Someone's stealing the electrons. The one that has a higher electronegativity has a partial negative. The one that has a lower electronegativity is partial positive. This last column, good to know, but you don't have to do this for the Regents nor the midterm. Should be aware of what this difference in electronegativity means. A couple Lewis dot diagrams, and then we talked about naming covalent bonds. And then we left off at the end of class talking about metallic bonds. Metallic bonds are 2 or more metals that bond together, or it could just be like copper, or it could be gold, or it could be a mix of copper and gold. They have few valence electrons. It's easy to steal the electrons. They have high melting points and boiling points. Metallic bonds result from the attraction for mobile valence electrons. Last but not least is hydrogen bonds. Hydrogen bonds, it has strong or high intermolecular forces. If something bonds with hydrogen, like nitrogen, oxygen, or fluorine, it is a hydrogen bond. Nitrogen, oxygen, fluorine. Since they're both nonmetals, they could be covalent bonds too. So H bonds with nitrogen, oxygen, or fluorine, NOF, or I say no other fools. No other fools, NOF, if they bond together, it's a hydrogen bond. And that is the strongest intermolecular force. It's really tough to steal away an electron from no other fools, NOF. Okay, next up, I'm going to go to another piece of paper, a fresh piece of paper here, fresh start like today. And I'm going to title this, I'm going to basically do this chart on one big piece of paper. It'll take like 20 minutes to do. So here we go. All right, the title is going to be Types of Bonds. Types of chemical bonds, I call this chemical bonds. And this will be like a nice review for you guys on ionic and covalent bonding. So this is something I would encourage you to write like on the midterm, separate piece of paper, or maybe even on the Regents Day. Because this is like a big review of everything we talked about, the bare basics of everything we talked about for like a good month and a half. So types of chemical bonds. Once you have that, I'm going to go right into the drawing board, and I'm going to try to recreate this little chart. And we drew this, I drew this a couple times in class. I told you, don't worry about copying it down. We'll copy it down later. Today's that day. So types of chemical bonds, I'm going to go to Insert, Drawing, New. This chart is going to be the change in electronegativity. So I'm taking a text box. I'm going to make a text box on top. This is a title here. So the difference in electronegativity. The change in, the difference. You should know it's subtraction. Difference in electronegativity. So when you take the change in electronegativity, if you subtract two values on electronegativity, which comes from page 10 and 11 for each element, then you could figure out, is it a polar bond? Is it nonpolar? Is it an ionic bond? So change in electronegativity. And with that, there's some values you should definitely know. So there's a range. The first one starting with a range from 0 to 0.3. 0 all the way to 0.3. So 0 to 0.3, the first text box, that window. And we know that this window, if we got electronegativity difference from 0 to 0.3, it would be a non-polar covalent bond. But I'll put that in there in a second. I'm also going to put a little line to indicate that window, that range. I'll thicken that up. So 0 to 0.3 is the first little range we're going to explore. But another value is going to be from 0.3 text box to 1.7. If I go too quick, or if you want to see something done again, please feel free to ask. So the next one is 0.3 to 1.7. I'm going to put a little line in between those two to represent that range as well. So 0.3 to 1.7 is going to be something else for in terms of bonds. And the last one is greater than 1.7. So I'm taking an arrow this time. Instead of a line, I'm just taking an arrow that's going to increase from 1.7. So again, that is everything greater than 1.7. A difference greater than 1.7 is another type of bond, which is an ionic bond. All right. So let's do the basic classification for bonding. If you have a difference from 0 to 1.7, that's called a covalent bond. If it's greater than 1.7, it is called an ionic bond. So 0 to 1.7 is covalent. I'm going to go to shape, equations, bracket. Take that little bracket right there, left bracket. And with that left bracket, I'm starting it at 0. I'm going to 1.7. 0 to 1.7. Anytime you get a difference from 0 to 1.7, we know it's going to be a covalent bond. So covalent. Or it's also called covalent or molecular bond. So covalent or molecular bond is in the window from 0 to 1.7. Covalent or molecular. So molecular is the same thing as a covalent bond. Again, I haven't said molecular much. They like covalent more, but you should know molecular and covalent. They're both nonmetals. Same thing. I'm going to take that text box that we just created. I'm going to flip it 90 degrees. I'm going to bring it over all the way to the left of the bracket. So a covalent or molecular bond is in that window. You can see that right there. 0 to 1.7. I'm going to do the same thing below for 1.7 to that arrow. We'll extend the arrow a little more. So 1.7 and beyond is an ionic bond. What I'm going to do, I'm going to take my shape equations left bracket again. I'm going to extend that to the tip of that arrow. I'm going to take a text box, create another text box, and say ionic bonds. Ionic bonds. Please rotate that around 90 degrees. Throw it into that little range for electronegativity difference. So ionic bonds, a metal and non-metal, if the difference is greater than 1.7, that's going to be proof it's an ionic bond as well. Well, I'm going to color code this too. So once you have that, I'm going to keep ionic bonds. I'll go blue with that. You don't have to color code yours. You don't have to, but I'm going to. So ionic bonds will go blue. Covalent bonds, I'm going to have two different colors for two different branches of ionic bonds. Start on the bottom. So ionic bonds, I'm going to put a text box here. I'm going to do some basic characteristics or properties for ionic bonds. So one text box, another text box, one big text box. And I'm going to change this font to blue again. This is going to be ionic bonds. We know that. And these are properties that would correspond to ionic bonds. So what's an ionic bond? I'm going to add a bullet. So that dot, 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 I'm adding a bullet. I don't care which one you add. I want stars today. An ionic bond is going to be a metal and a non-metal. Metal plus a non-metal. An ionic bond is going to transfer electrons. An ionic bond has an electronegativity difference greater than 1.7. An ionic bond could be a binary compound or ternary compound. And an ionic bond has something called the low intermolecular force, which is called IMF, intermolecular force. What does that mean? It's the attraction for the electrons between both atoms. So that means it doesn't really hold on to its electrons very closely. It transfers it away. Therefore, it's going to lose it pretty easily. During that transfer, during that throw of electrons from one atom to the other, you could easily just snag it, intercept it out of the space. We'll pretend to say that. Ionic bonds. It's a metal and a non-metal. They transfer electrons. Its electronegativity difference. Put EN up here so you know that code. Electronegativity difference is greater than 1.7. So anything greater than 1.7 is an ionic bond. there's my little checklist. It's a metal and non-metal. It's going to transfer electrons. It has an electronegativity greater than 1.7. It can refer to a binary compound or ternary compound, and it has a low intermolecular force. Ionic compounds. Spend a ton of time. We also could name them. You could do gram formula masses. You could do percent composition for ionic compounds or any molecule now. There's ionic bonds. Next one, go to the next one in the range from 0.3 to 1.7. I am adding another text box here. I will color code this. This is called a polar covalent bond. Polar covalent bonds. I'll go red this time. Polar covalent bonds, you can see the window of a polar covalent bond. All right, information about a polar covalent bond. What should we know about this? I'm adding a bullet again. For polar covalent bonds, it's going to be at least 2 nonmetals. We should know that they share electrons when they bond. We should know for a polar covalent bond the electronegativity difference is 0.3 to 1.7. It's in that window. It has a pole of electrons. I'm going to switch something above. Share of electrons, yes, but it's going to be unequal sharing of electrons. Share of electrons unequally. It has a high electronegativity, or sorry, a high intermolecular force. Say relatively high. Because the highest one's going to be nonpolar. Relatively high intermolecular force. And one thing I really did forget to put up here, polar covalent bonds, they have a pole, has a pole. Pole towards what? Pole of electrons. Polar has a pole. Someone's hogging. Someone's grabbing those electrons and pulling them towards them. That's what that means. Has a pole for electrons. Polar covalent bonds. They have a pole for electrons. There's 2 nonmetals. They share electrons unequally. Has electronegativity difference from 0.3 to 1.7. Relatively high intermolecular force and asymmetrical. So as you drew it, it'd be an asymmetrical shape. Lewis, that diagram would be asymmetrical. Last but not least, let's do the nonpolar covalent bonds. Put this all the way at the top. I'm going to just mock what I have below and just edit it to make it fit here. A nonpolar covalent bond. I'm going to color code this a different color. Let's go purple. Nonpolar covalent bond. Nonpolar means no pole for electrons. They're sharing them. No pole for electrons. Nonpolar, no pole. That was like the first thing I put in the notes. Nonpolar means no pole. I'm at a bullet. Nonpolar covalent bonds. If it's covalent, it's got to still be 2 nonmetals. They got to share electrons. But this time, since there's no pole of electrons, they share electrons evenly or equal share of electrons. Equal share of electrons. They have an electronegativity difference. You can see at the left, it's going to be from 0 to 0.3. I don't know why I put a G there. It's not grams. So 0 to 0.3. This is a high or strong intermolecular force. The strongest one is actually going to be hydrogen bonding. The strongest attraction for electrons. And one's going to hold together the strongest is hydrogen bonding. And then nonpolar would be the second strongest attraction for electrons or sticking together between atoms. Then it would be polar. Then it would be ionic. And the lowest intermolecular force would be metallic bonding. So it's a high intermolecular force. Last thing is going to be it's symmetrical. You've cut it in half. It's going to be the same thing on both sides, meaning it's symmetrical. Okay, and that's the information you should be aware of for the chart that I wanted you to complete for obviously difference in electronegativity. A lot of information that is on this chart. Hopefully you understand most of this or all of this information that we made on this chart. I'll give you a minute to finish it up. So covalent bonds are, or molecular bonds. It's going to be two nonmetals. They share electrons. That's a common trait. One shares them equally, one's going to be unequal. The electronegativity difference is a little bit different for them. And the shape's a little bit different. One's symmetrical, one's asymmetrical. Once you have that chart, you can save it and close it. That concludes the notes for unit number 5. So that chart right there, if you have access to a printer, I'd probably print that out. That's something you can use for review all throughout the year. So when I review this unit, this is something I'd review. Definitely going to help you out. Does anybody have any questions on anything about that little diagram chart that we just made? What does this mean? What does that mean? When do you talk about that? So types of bonds. Does anybody need more time? All right, so the 4 types of bonds that, the 4 types of bonds that you have ionic bonds, which is a metal and nonmetal. You have covalent bonds, which is 2 nonmetals. There's 2 branches of covalent bonds. There's polar, which has a pole of electrons, and there's nonpolar, which is no pole. So polar and nonpolar are branches only for covalent bonds. 4 types of bonds: ionic bonds, metal and nonmetal. Covalent bonds are 2 nonmetals. We have hydrogen bonds, which H bonds with no other fulls, nitrogen, oxygen, or fluorine, or metallic bonds. So 4 types of bonds: ionic, covalent, hydrogen, and metallic bonds. Know them. There's 2 here. I don't have, obviously, hydrogen bonds or metallic bonds on this chart. Obviously, the 2 that are more important are ionic and covalent. Hydrogen and metallic, small little section you have to be aware of. So some people ask for more time. I'll give you 2 more minutes to finish it up if you need it. Once you're done, you could submit this to me. You could share it, whatever you need to do. If you don't share it to me by Saturday, I still will grade what you have there. If you need to catch up on something, feel free to watch one of these videos. At the beginning of class, I scroll through all the notes. You could pause it wherever you need to fill the notes out, and you could fill in the missing link there as well. In the meanwhile, since people still need more time, I am playing CO2, the video on CO2. I'm not gonna play this tongue bonding song. I would have went through this again. I wouldn't have sang it to you with a duet, but instead I would have actually went through the bonding interaction, and we just talked about what happened there in each of the bonds, each of the atoms. This video right here is gonna be the chemistry of CO2. So now that we know about carbon dioxide, you'll know the effects of carbon dioxide that it has in the environment. Enjoy.
It's one of the few molecules regularly named in daily headlines, lead stories, and public conversation.
Plants emit some 2.1 billion tons of carbon dioxide a year.
Regulated vehicles, carbon dioxide emissions will be reduced by 9.
Biggest producer of carbon dioxide.
Carbon dioxide,
for chemicals like carbon dioxide.
Leading cause of global warming.
What's behind the headlines on carbon dioxide? Here's the inside story. Really inside, down to the molecular level, as you'll see. To start, carbon dioxide, or CO2, is a gas, colorless, invisible at standard pressure and temperature. Under high pressure, CO2 can be compressed into a solid, known as dry ice, or dissolved in water, a process called carbonation. It's CO2 gas bubbles that put the pop in pop, or soda, depending on what part of the country you're from. And being a gas can make you burp. You can also see CO2, or at least its effects, when you make bread. Yeast eats the starch in the flour and expels carbon dioxide gas. CO2 gas expands when warm and makes the dough rise, the way helium gas expands a balloon. That's not the way most people relate carbon dioxide to warmth and warming. This is. The relationship of complex fluctuations in global temperatures, ice cover, and sea levels to this remarkably simple common molecule made of only 3 atoms. 1 atom of carbon, the C part of CO2, attached or bonded to 2 atoms of oxygen, the O2 part of CO2, in a linear structure. Great opportunity here to explain one of the fundamental rules in organic chemistry, the octet rule, or rule of 8. A rule worth knowing because it applies to most elements in the periodic table, including the most common, carbon, nitrogen, and oxygen. Okay, hit refresh here. Atoms have a center, a nucleus, and a certain number of electrons that orbit the nucleus in shells. Molecules are formed when atoms combine. Atoms of most elements tend to combine so they each have 8 electrons in their outermost shell. Carbon dioxide is a great example. A carbon atom has 4 electrons in its outer shell. It needs to connect with 4 more electrons to get the magic 8. An oxygen atom has 6 electrons in its outer shell. It needs to connect to 2 more to get to 8. What happens is a little like the card game Go Fish, atomic version. The atoms align in specific ways to trade or share electrons so they can get the electron sets of 8 they need. 2 oxygen atoms connect to opposite sides of 1 carbon atom, which gives each the 2 electrons it needs to make 8. See? The carbon atom in the middle gets 2 electrons from the oxygen atom on one side and 2 from the one on the other, for a total of 8 in its outer or valence shell. Sharing of pairs of electrons is called covalent bonding. Now, back to the bigger picture, CO2 in our air and atmosphere, and in fact throughout deep space, in ice form, part of the makeup of planets. NASA rovers found CO2 ice caps on Mars. Earth's surface is much warmer than space, so most of the CO2 on Earth is present as an atmospheric gas. Carbon dioxide makes up less than half of 1% of the air we breathe. Air is mostly nitrogen and oxygen. Eruptions of volcanoes, like the one in Iceland add CO2 to the atmosphere. And of course, so does the carbon or life cycle. Plants take in CO2 along with sunlight and water and give out oxygen. Animals and humans take in oxygen and give out CO2. And then there's this, the burning of fossil fuels in power plants, automobiles, and factories. Oil, gasoline, coal, carbon-based fuels. In fact, the word carbon comes from the Latin word for coal. As more of these fuels and organic matter like wood and crop stalks are burned by the planet's growing population and industry, all this additional carbon does exactly what you've just seen. It bonds with oxygen in the air. Air is 20% oxygen and makes, yes, more carbon dioxide. Where does it all go? An estimated 57% of this cook-fire tailpipe smokestack carbon dioxide is cycled into the oceans, covering 70% of the Earth's surface. Plants eat up some, most of the rest goes into the air. In the oceans and the air, more CO2 is causing serious problems. In the oceans? Well, quick rewind to making carbonated drinks. Remember, by dissolving CO2 into H2O, that, logically enough, makes H2CO3, also known as carbonic acid, a weak acid, although strong enough to remove rust from chrome. Okay, fast forward again. More CO2 in seawater, more carbonic acid, more acidification of the oceans. And in the air, buildup of CO2 and other so-called greenhouse gases in the atmosphere acts like a marathoner's thin post-race blanket, holding essential body heat close to Earth's skin, keeping the average surface temperature at about 59 degrees. Without this trap, the warmth from the sun would escape back into space, and average temperature on Earth would be just below 1 degree Fahrenheit. But adding too many layers of CO2 can have the opposite effect, trap too much heat, enough to melt ice caps, raise ocean levels, raise ocean and air temperatures, contribute to global warming. There's much more to know about CO2 and carbon credits, carbon footprints, and carbon capture. Maybe think of this video as carbon capture of another kind.
Okay, so there's a little more information about the environmental effect of carbon dioxide. Hopefully you can see the interaction around the environment, news, all this stuff when you can make these connections with atoms as well. All right, so there's not a ton of time left for class, so we're going to end up with the cool down or the warm up on covalent bonding. So it's above on the stream. Please click on the midterm review 1/20/21 midterm review for Unit 5 covalent bonding. From now to the end of class, we'll do this together. We'll do several questions. I'll give you like 30 seconds to try it, and then we'll go over the questions. Wherever we end up in class, we'll pick up next time. So here we go. It looks like this. You probably want your reference table, and maybe you want your notes as well. I'll leave this here, and I'll leave my reference table handy. And we're going to try these questions out. So instead of giving you guys like 15 minutes or 10 minutes to work on this by yourself, we're going to take 30 seconds to try each question. So it's a little bit more rapid for these questions. Which compound has a covalent bond? Which one has a covalent bond? Please try your best. Give me a 30-second timer starting now. Try it out. All right, question number 1, please put your answer in the chat. Best answer, which compound has a covalent bond? Thank you. Awesome, thank you. Quick responses on that one. So which one has a covalent bond? We should definitely know covalent bonding is going to be 2 nonmetals. Covalent bonds, it's got to be 2 nonmetals. you're trying to figure this out where two nonmetals are in the reference table here. So if I know covalent bonds are two nonmetals, then I look at the reference table and say, oh, where's my two nonmetals? Check it out. So I'd highlight this and say, oh, nonmetals. Let's see here. We have H and O. Find your H, that's a nonmetal. Find your O, that's a nonmetal. That looks like a covalent bond. Find your Li and O, there's my Li to the left, alkali metal, and O, that would be an ionic bond. Next one, check out Na and O. Na is a metal, O is a nonmetal, that's a ionic bond. And last we have K and O. Okay, there's K, alkali metal, and O is a nonmetal. That is an ionic bond too. Best answer is definitely choice A for number 1. A covalent bond, two nonmetals. H is a nonmetal. Don't forget that one. Number 1 is choice A. Next up, number 2. Covalent bonds are formed when electrons do what? 30 seconds on the clock. Okay, please put your answer in the chat. That's 30 seconds. Awesome. Nice participation today. Thank you. And they look like they're all the same answers. We just put this there as well. Covalent bonds, electrons are shared. Oops. Electrons are shared. Shared electrons, covalent bonds, molecular bonds. They're shared between two atoms. Choice D is the best answer for number 2. 2 is D. Next up, number 3. What's the maximum number of covalent bonds that can be formed with one carbon atom? 30 seconds. Give it a shot. Okay, please put in the chat. Thanks, Mike. Thanks, Irvin. Tintin, thank you, Micaiah. Thanks, Zen. Check that one out. Okay, couple different answers. No big deal. Carbon. So there's my carbon. If I drew a Lewis dot diagram for carbon atom, hopefully we know what it would look like. This carbon. Number of valence electrons are electrons in the outermost shell. There's 4 dots in the outer shell. How many bonds could potentially have? I would ask you how many H's would bond with that thing. An H has 1 valence electron, an H could bond there. Another H could bond here. Another H could bond there. Another H could bond here with 1 valence electron, creating a stable octet for carbon. Count all those dots in between. There are 8 dots. It's a stable octet. And that would be how many bonds it could have. So 1, 2, 3, 4. Carbon, 1, 2, 3, 4. Remember, we made this. This was a tetrahedral shape. So CH4, 4 bonds. 4 is the best answer for number 3. 3 is D. 3 is D. Number 4, in a non-polar covalent bond, electrons are what? 30 seconds. Okay, please put in the chat. Cool. Yeah, C is the best answer. Looks like everybody has that one. Non-polar covalent bonds are shared they are shared equally. Choice C. C is the best answer. Equal shared. Non-polar, no pole. Sharing electrons equally. Choice D would be obviously polar. Choice B is ionic. Choice A, mobile C, electrons, ions, that would be metallic. So choice C, equal sharing. Number 5. Try this one on out. Number 5. Which molecule contains a non-polar covalent bond? Non-polar covalent bond. Please try it out. Okay, so number 5. Please throw your answer in the chat for number 5. Non-polar covalent bond is yes, Kai, yes, Asim, Tintin, good. Thank you, Michael. Thanks, Alex. Nadina, thank you. Thanks, Zen. So if you're not recording your answers in the chat, hopefully you're attempting. Hopefully you're not just dazing out and watching the live action DC right now. All right. Non-polar covalent bond, no pole, sharing of electrons, covalent bond. So first thing, non-polar covalent bond, 2 nonmetals, they share electrons unequally. The difference is from 0.3, 0 to 0.3. So the first thing I would do is figure out, are they metals or non-metals, to see if I can eliminate any that way. So my first step in the process would be to find the elements. There's H, non-metal. There's Cl, non-metal. 2 non-metals, definitely got to be a covalent bond. You can't get rid of that. F2, F, there's 2 Fs, non-metals. Can't get rid of that. Next one is CO2. Carbon's a non-metal, O is a non-metal. Can't get rid of anything there. Last one's NH3. Nitrogen and hydrogen. There's my nitrogen, non-metal, and hydrogen, non-metal. All right, so I couldn't get rid of anything just like that. My second thing to do, maybe you want to make a Lewis dot diagram. Maybe you want to go through and make, or determine the electronegativity difference. Quickly, the Lewis dot diagrams for these would look like this. H has 1 dot, 1 valence electron. Cl has 7. It creates a single covalent bond right there. Single covalent bond. F2, F has 7 dots. There's 2 Fs. Each one has 7, needs 1 more. That 1 more you need goes in the middle. So 1, 2, 3, 4, 5, 6, 7. This F to the right has 7. It needs 1 more. That 1 more you need has to go in the middle. 6, 7. That creates a single covalent bond right there. CO2, watch a flick on that. There's carbon in the middle, 2 oxygens. Carbon has 4 valence electrons. It needs 4 more. It gets 2 from the oxygen, and it gets 2 from the other oxygen. Oxygen has 6 valence electrons. 2, 3, 4, 5, 6. This oxygen has 6 electrons as well. That'd be CO2. The last one's NH3. NH3. Run out of space here. N has 5 dots. 1, 2, 3, 4, 5. And H's have 1 dot. H has to go there. There's an H here. There's an H here. All right. Another thing to note about nonpolar has to be symmetrical. That means if you cut it in half, it's the same thing on both sides. So I'll see if I cut some of these in half, what happens. Cut this guy in half, fold it on over, flip that on over. Are they the same on both sides? No. That's not going to be symmetrical. And then you're like, oh, how do I cut this thing? How do I cut my CO2? F is pretty easy to cut, though. Cut that in half. It's the same thing on both sides. That looks like it might be a good choice. But maybe you're still stuck and saying, what the heck do I do now? Take your electronegativity difference and subtract each element. So H and Cl. So H has electronegativity of 2.2. Cl has electronegativity of 3.2. So take 2.2 minus 3.2. Subtract them, you get 1.0. Where's 1.0? 1.0 is right about there. That'd be a polar bond. Oh, it's a polar bond. No, that's not the right answer. Why is it polar? Because it's pulling electrons to the right. Cl is pulling in the electrons. That's slightly negative. This would be slightly positive, but it's definitely not that answer. F2, check out the electronegativity values. F has a value of 4.0 for electronegativity. So in this situation, you're taking 4.0 minus 4.0. Difference of 0. I know this is like messy. A difference of 0. If I look at my scale, 0 is definitely going to be right there. It's a nonpolar covalent bond. Best answer, a lot of you guys put it, was choice B. You could do the difference for the rest of these, and you'll notice it's going to be, those ones are going to be polar covalent bonds. So those you could check out too if you need to. All right, guys, I'm going to stop there today. We have 1 minute left of class. Have a great day. Make good decisions. You have an extra pass to do for metallic and hydrogen bonding. I will do the rest of this warm-up next time in class. So 6 through 20 we'll do together. That'll be our warm-up. I won't play any other random videos, but I thought it was an important piece of history today. So have a good day. Make good decisions, and be kind to one another. See you guys. Bye, Micaiah. Bye, Kai. See you, John. Have a good one. See you Friday. Yeah, that's right. See you Friday, guys. Bye, Kim. See you guys. Have a great day.